Good morning and welcome to the live broadcast for Rocket Lab's latest Electron launch, a dedicated mission to low Earth orbit for Sinspective. My name is Kim Thompson and I'm here with Matt Tier. It's great to be joining you from Rocket Lab's Mission Control Centre in Auckland as we count down to launch from our private launch site at Mahia, New Zealand.
Thanks, Kim, and thanks to you at home for joining us. We'll be taking you through today's launch activities, which will deliver a single Earth observation satellite to a Sun-synchronous low Earth orbit. We're just 17 minutes away from our scheduled liftoff time of 7:10 a.m. New Zealand local time or 18:10 UTC. For our viewers in the States, that's 2:10 p.m. Eastern and 11:10 a.m. Pacific.
Well, the weather at LC1 is currently green with an 80% chance of launch today. All systems are currently go for an on-time launch.
Today's mission is called 8 Days a Week in a nod to the famous Beatles song and also for the 8th StriX satellite we're deploying for Japanese company Sinspective. They specialise in synthetic aperture radar data and solutions, also known as SAR.
That's right. Unlike a camera that captures images using light, Sinspective's SAR technology uses radio waves to capture imagery from space. As these radio waves bounce back from things like mountains, trees, and buildings, the satellites measure the differences to create a detailed picture. That data can then be used for things like urban development planning, construction and infrastructure monitoring, and disaster response. Here's more from Sinspective.
We are developing and operating the synthetic aperture radar satellite to understand our Earth scientifically, quantitatively, and rethink about the economic activity, climate change, or disaster mitigation. Then we provide the insight and needed information to the governmental users and the private sector's users.
The SAR satellite can operate without light. At any time of the day, even at night, or even when there's rain, to detect objects on the ground. We are able to play a role very much in weather adverse scenarios, for example, in flooding, in typhoons.
We work on using the disaster damage assessment solution to quickly output some disaster area estimation to send to local agencies so they can use it for the local relief.
And also we can expand the collaboration with other sensors, maybe comes from our partner companies, to accelerate the resilient world. So I think a very hopeful approach.
Electron has been the sole launcher for Sinspective's constellations since our first mission with them back in 2020. It's been a great run of missions to build out their constellation, so let's take a look back at the previous StriX launches to date.
And right now we're only a couple of minutes away from sending the 8th StriX to space and expanding their Earth observation mission. In fact, after this one, we have another 19 upcoming missions with the company to deliver the rest of their constellation to orbit before 2030. So you'll be seeing plenty more owl-themed mission patches on Electron's fairing, both throughout this next year and into the next.
All right, clock is ticking, and soon our operators will run through the go, no-go poll led by our missions launch director, Taylor Moore. This is our final readiness check to make sure every critical system is green before committing to liftoff. Each operator is polled by the LD. They'll either respond go to proceed or no go if something needs to be addressed. If we clear the poll, the LD will confirm across the nets in real time, so let's throw it over to the launch director.
To all operators, we're proceeding with the go, no-go sequence, commencing with stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Decon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LSO.
LSO is go.
LD sub.
LD sub is go.
The go, no-go sequence is complete. We are T-minus 11 minutes, 22 seconds and counting. We are go for terminal count at auto sequence at T-minus 10 minutes. At this time, the 3-word procedure is in effect.
There you have it. That is confirmation from Mission Control that all systems are healthy, and we'll be proceeding with the remainder of the count. The T0 liftoff time remains set at 7:10 a.m. New Zealand local time or 18:10 UTC.
We've got one attempt today, but plenty of other opportunities throughout the coming days if we do need to recycle for another attempt.
So as that countdown continues to today's launch, it's worth remembering that every mission is often part of a much bigger journey, sometimes ones that extend even far beyond Earth's orbit. In the coming years, NASA is preparing for a new era of exploration of Mars, one that includes boots on the ground with astronauts on the red planet.
Yes, and while launches like today are supporting missions closer to Earth, we've got plans for a Mars telecommunications orbiter for NASA that will bridge the distance between Earth and Mars. Let's take a closer look.
The Mars Telecommunication Orbiter is about providing broad support for future science programs, but most importantly, MTO is about taking the first step towards expanding human exploration to Mars by providing communications and navigation support, the kind of high reliability, persistent communications required when we send humans. So to do a mission like MTO, you need a few ingredients. You need a launch vehicle, you need spacecraft, you need payload technology, and you need all the ground support to operate and sustain the mission over time. These are the kind of missions that we were built for. Our experience with Mars missions like the Mars Escapade demonstrates an ability to execute on these challenging programs. Our whole company was set up for affordable planetary science. That's been our strategic North Star from the beginning. Started early with the capstone mission to the moon, demonstrated an ability to do high delta V missions and really challenging operations in deep space. And so that was really the program that forged in fire the capability that we then applied to the Escapade program. The Escapade mission has basically demonstrated the mission model of affordable planetary science. We have 2 spacecraft, happy and healthy, in their Lagrange orbit, waiting for the Mars escape asymptote to come into alignment and continue on to Mars. Rocket Lab's vertical integration is really one of the key ingredients on our ability to not only move quickly and affordably, but to meet challenging mission requirements. Eliminating the organizational interfaces between the launch vehicle and the rocket, between the payload and the satellite, and then of course relying on our manufacturing scale is really critical to being able to commit to the ambitious schedule that MTO demands. Getting this program moving and selecting a partner like Rocket Lab that has high confidence in execution allows the agency to move on to the next challenge.
We are so ready to go to Mars with a telecommunications orbiter for NASA.
T-minus 8 minutes on the clock, and before we take you through Electron on the pad for today's launch, you might have noticed that the fairing for today's mission looks a bit different than usual. That's because we've rolled out another one of our bespoke Electron fairings. It's been shaped to fit the wide body of the StriX satellite on board this mission. The configuration for today's launch is called the Arrowhead fairing, which has been the custom solution we've deployed across several Synspective launches now.
We actually used another custom fairing for our recent HASTE launch out of Wallops Island, Virginia. The fairing on that rocket is one of the longest fairings we've made to date. It's an option that we use for taller than normal payloads or dual stack missions with more than one spacecraft on board. Custom fairings mean we're able to serve a broader range of missions with our launch vehicle, as well as eliminate the constraints satellite manufacturers face when they're forced to build to standard fairing options. So, it's great to see another custom fairing being put to good use for today's mission.
So, let's take a look at it. Electron typically stands at 18 meters tall on the pad and is a small lift carbon composite rocket with many other unique features. It carries up to 300 kilograms to low Earth orbit and sometimes even higher, like when Electron launched a spacecraft to the moon for NASA just a few years ago.
Electron uses advanced carbon composite materials for its structure and propellant tanks, giving it a high strength to weight ratio. This is a crucial benefit when it comes to launching dedicated missions for small sats, since lower mass means the rocket requires less fuel to reach orbit and can carry out more complex or heavier missions. Its engines are called the Rutherford, and they're unique in the industry too. We leverage 3D printing and electric pumps to bring those engines to life.
That's right, we use additive manufacturing for the combustion chamber, injectors, main propellant valves, and pumps. It's those pumps that are driven by electric motors powered by batteries, adding another item to the list of world firsts.
Once those engines on the first and second stages take us all the way to orbit, we employ another unique feature of Electron. The kick stage is our orbital transfer vehicle on top of the second stage. It acts like a highly maneuverable spacecraft that carries the mission satellite to its final destination on orbit. The kick stage has its own propulsion system called Curie. This is a highly capable, relightable 3D printed engine, allowing us to adjust altitude and inclination and even deploy multiple satellites into different orbits.
And looking at the time right now, we're almost ready to head to space. Today we're launching from Pad B at Launch Complex 1. Here's what's about to happen next. Just before the team moves into what's known as the final count, or the last 2 minutes before liftoff, Electron will have received a final top-up of its liquid oxygen propellant. Then, at T-minus 2 minutes, the team conducts a final check. This check ensures that the propellant levels are in bounds before closing the tank vents. This is why you'll stop seeing those small white puffs of vapor near the top of the rocket.
By this point, Electron's flight computer will have taken over to run some of the final automated sequences and complete the usual checklist before launch. Electron's Autonomous Flight Termination System, or AFTS, will be locked and ready for the moment the rocket leaves the pad to manage the launch's safety parameters. Electron's first and second stages will then also be fully pressurized ahead of liftoff, and then our launch director will count down from T-minus 10 seconds along with the mission clock. Now, since T0 is the exact moment Electron lifts off the pad, the engines will actually ignite just a couple of seconds before then to power up to maximum thrust for liftoff.
We're just moments away now from those final actions. So, we're going to bring up the audio channels from Mission Control to listen in. Then, we'll be back to you after liftoff. Go Electron, go Sinspective, go StriX.
To all operators, from now on, there should be no red flags in your critical LCCs. Beacon LD on mission card.
LD Beacon.
Please lock the auto sequence and confirm.
Auto sequence is locked.
And confirm all flight computer ASCOs are green.
Confirmed all ASCOs are green.
Copy Beacon. We are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
The vehicle is fully on the entire bar. AFTS is green, enable flight.
LOX load complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and 2 tanks suppressed.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Beginning virtual work.
Stage 1 propulsion nominal.
There goes Electron up and over the Mahia Peninsula and on its way to space once again for Synspective. Electron is now 43 seconds into flight, climbing nominally in both speed and altitude. Now, our first milestone during this phase of flight will be when Electron passes through maximum aerodynamic pressure. That's the moment that the structural loads against the rocket are at their strongest on the way to space.
Approaching max Q. Cleared max Q.
Great call out there from Mission Control. That's a clean pass through max Q. Those 9 Rutherford engines on the first stage are throttling back up to full power. The vehicle is travelling at more than 2,000 kilometers per hour. We now have less than a minute to go before we reach the end of the first stage burn.
Yes, the moment that those 9 Rutherford engines power down is what we call MECO, or main engine cutoff. That action takes place just ahead of Electron's second stage separation event, before the vacuum-optimised Rutherford engine on stage 2 lights up to continue the mission to orbit.
And we'll watch those moments live on our screen from the onboard camera feed. You should also hear the call-outs from Mission Control across the audio feeds. It will then come at you quick and fast, so let's listen in.
15 seconds to staging.
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
Stage
Great
2
job
guidance.
there by Electron. That was a successful MECO, stage separation and second stage ignition at more than 90 kilometres above Earth. And that second stage Rutherford engine is performing nominally as we'd expect, powering the vehicle and its StriX satellite on board past more than 7,800 kilometres an hour. Otherwise, the next action to take place will be the separation and jettison of the Arrowhead fairing from Electron to expose StriX to space for the first time. Here goes.
Jettison confirmed.
Screen is the latest StriX satellite for Synspective. It's heading closer and closer to orbit to join the rest of the constellation in Leo. We've got just under 6 minutes of engine burn time through to second stage separation from the kick stage. Electron is now hitting speeds of more than 8,500 kilometers an hour.
Well, as you can see by the dials on your screen there, Electron is climbing nominally in both speed and altitude. We're also working through our propellant, now with 74% of kerosene remaining and 74% of LOX. That stage 2 nozzle continues to glow hot, powering Electron and StriX towards orbital insertion.
Stage 2 propulsion is holding nominal.
The second stage Rutherford engine on your screen includes some slight modifications. This allows it to operate nominally in the vacuum conditions of space, but it's otherwise much the same as the sea-level Rutherford engines on the bottom of the first stage. Since the second stage engine burns longer than the first stage, the pumps on this engine variant need more power. Battery power, in fact. So up next is an action that swaps the worn-out battery packs for a fresh new set.
That's right, we call this the battery hot swap, which is something you'll only find on Electron and our Rutherford engines. Today's battery hot swap is scheduled to take place at around 6.5 minutes into flight, so not too much longer to go now. When it happens, the old battery packs will be ejected from the second stage and fall away. It's a pretty quick disconnect, so keep your eyes on the screen to spot that battery hot swap the moment it takes place.
AGV discharge is holding nominal, approaching hot swap in roughly 30 seconds. Throttling down.
Battery jettison confirmed.
Hot swap successful.
Good confirmation there from the team in Mission Control. We have a fresh set of batteries in place on that second stage Rutherford engine. That allows us to continue the mission to our next separation event from the kick stage. Electron will repeat the same actions for the second stage as it did with the first stage. That includes SECO, or second engine cutoff, this time followed by separation between the second stage and the kick stage. It's released at the orbital velocity required to place the satellite into Leo.
When the kick stage is separated from the second stage, it's placed into what we call a nominal transfer orbit. Because it's initially released along an elliptical trajectory from the launch, the kick stage has a coast phase around the Earth to complete before it can reposition itself into a circular orbit.
The time from launch to SECO takes less than 10 minutes. That means we're coming up on kick stage separation very quickly. Now again, much like earlier separation events, Electron's flight computer is preparing to shut down the second stage engine for SECO, after which the kick stage is released along its elliptical coast trajectory. So keep an eye on your screen as that engine nozzle should start to cool once engine shutdown takes place.
Entered burnout detect mode.
Guidance terminal, 20 seconds from heading.
SECO confirmed.
Stage separation confirmed.
Just what we wanted to see and hear for Electron's kick stage and StriX, successfully in an elliptical orbit for the 8th time on board Electron. Now, as we said before, we go into a bit of a coast phase to allow the kick stage to circle around the other side of Earth before payload deployment. Once that initial journey is complete, the Curie engine on the kick stage will light up to circularize its orbit, and then we'll be only a minute or two away from payload deployment and the end of the mission.
So stretch your legs, grab a drink, and join us back here in about 40 minutes or so when we'll listen into mission control for the final calls. See you soon. Cheerio.
Hello and welcome back to our broadcast for the 8 days a week mission on Electron. Our 8th mission for constellation operator Synspective is coming to its final moments before payload deployment with the latest StriX spacecraft.
We had a successful liftoff today at 7:10 local time from Rocket Lab Launch Complex 1 in New Zealand. Today's launch is our 5th of the year, but 84th mission overall, and we're just moments away from deploying our 250th satellite to space from Electron. While off air, the kick stage carrying the StriX satellite completed a coast phase around the Earth. That's before lighting up its Curie engine to course correct the mission for its 573-kilometre low Earth orbit deployment.
Yes, engine shutdown is about to occur, and then a few seconds after that is when the kick stage is scheduled to deploy the StriX satellite to space. So let's listen in to mission control.
Curie cutoff confirmed.
All right, good comms there of Curie shutdown. That means payload deployment is next. We've got an animation of that sequence so we can track what happens in real time. So we'll bring that up now and listen in to mission control.
Payload separation confirmed.
Nominal final orbit achieved.
And that is payload deployment confirmed and mission success once again for Electron and StriX. Welcome to orbit once again, Synspective. All the very best with the satellite commissioning to come.
That's 8 down and still another 19 missions to go for this Earth imaging constellation for Japan. It's fantastic to see another StriX satellite delivered to orbit by Electron. Now, don't forget to keep us in your orbit by following us on the socials, and of course, if anything you've seen today excites you, we'd love for you to check out the careers section of our website at rocketlabcorp.com to see how you can join the Rocket Lab family. We're recruiting across all facilities: California, Colorado, Maryland, Mississippi, Arizona, Virginia, New Mexico, Toronto, Canada, and of course across our New Zealand facilities.
Well, that's a wrap on today's launch coverage, so thank you as always for joining us. We'll be back again in just a couple of days' time from Launch Complex 1 with our next dedicated launch, this time for the European Space Agency from the pad right next door to today's launch. But until then, this is Rocket Lab Mission Control signing off.